Okay, good morning. So we're going to start by having a look at the question 3 activities on compete.withcode.uk. Remember, these are preparing you for the on-screen Python test. You are pros now at typing. We did that to avoid any frustration with coding from not knowing where to put your fingers, but you know what to do with that now. So you start with the K-Pride activity. The K, keyword comprehension, is really good for questions 1, maybe question 2 in the on-screen test. But the most useful thing for us now is the extensions. So this week we're looking at the type of questions that might come up in the 3rd out of 6 questions. And we've got 3 practice ones. The video goes through one of them, and then there's 2 more practice ones to have a look at. For example, what type of things have we got here? So here, it's about fixing syntax errors. If you've been doing the K-Pride, the D of pride is about debugging. You'll be pros at this. You've got some code which is broken. You just have to interpret the error messages and use the clues to solve the problems. So watch the video, work your way through. Anything you're not sure about, ask me. I'm not going to go through it now because it's in the video. Today, we are looking at linear searches through one-dimensional lists. We want to know what a linear search is, how to do it in a flowchart, and how to write it in Python. So, if I ask you to find the number 77, how would you describe where it is? Good. So we've had a little discussion about how we found 77. You look at the whole thing and your brain is able to do multiple things at the same time. A computer cannot do that. A processing unit, a single processing unit can only look at 2 numbers at the same time. If you want to be able to look at all of these at the same time, you need lots and lots and lots of processing units. That's how a graphics card works. But a CPU, rather than a GPU, can only look at 2 numbers at once. And it can say, is this what I'm looking for? What is it that I'm looking for? That's the other number I'm comparing. So is that equal to 77? Is that equal to 77? And you keep going through in order until you find it. That's essentially a linear search because you're going through in a line, linear, straightforward fashion, until you find what you're looking for. People always say that when you're looking for your house keys, isn't it amazing that it's always in the last place that you look? To be honest, I think that's a stupid expression, because if you find your house keys and you carry on looking for your house keys, well, it's not a very clever thing to do, is it? Let's be honest. So when you find what you're looking for in a linear search, you stop looking. You're done. So, how do we do a linear search? You look at each item in a list or an array. You compare it with what you're looking for. If you can't find it, you keep looking. That's it. That's really it. We're not going to make it more complicated than that. So how do we do it with a flowchart? Well, we're going to start looking at the beginning. Index is where we're looking. We ask for what we're looking for. We said we're looking for number 77, but it could have been any number. We look in our list at the place that we said we're going to look at, and we're saying, is that what we're looking for? Have we found what we're looking for? No. If not, increase this number to 1. Increment. Increase it by 1. Have we gone outside of the list? Have we gone beyond the list? Have we run out of space to look for it? No, that means there's more spaces to look, and we'll keep going around. This looks like a while loop to me. So although this is selection, it looks like if. It's actually a while because it's a loop. It keeps going round. Have we found what we're looking for? Is there still more space to look? Keep looking until suddenly, we found what we're looking for. We'll return where we were looking, and we're done. However, if we keep going and we can't find what we're looking for until we run out of spaces to look, we say we haven't found what we're looking for, return -1. -1 means, I can't find it. It's a position -1. There we go. Let's have a look at the instructions then, shall we? We're going to look for a person. Let's have a look and see what we've got to do here. We step through. First of all, we've got len list. It's a built-in function. What is the length of the list? How do we calculate it? 1, 2, 3. I'm not going to count all the way through, but how many items are in the list will be the return value from len list. Let's go. This is CT22 in half term 4. Let's make a start. So let's go through part B together. It says dry run, that means do it by hand. The linear search algorithm, that means start at the beginning until you get through to the end. For target equals Castillo, that means that's what we're looking for. List all the values of index as they change. So index is set to 0 over here. Then we get the target value. The target value is Castillo. And then, is what we're looking for at position index 0? No, we haven't found it. So we increment index. There we go. Have we got to the end of the list? Is index greater than the length of the list? No. Let's go round again. Have we found Castillo? Nope. So we increment index up to 2. Have we found what we want at 2? Nope. So we increment it. Have we found what we want at 3? Nope. Have we found what we want at 4? 5. What is it? Sorry. 0, 1, 2, 3, 4, 5. And then when we increment it to be 6, index is equal to the length of the list. So therefore, final value of index is 6. What's the final value of index? Hang on. No, sorry. What does the final value of index represent? That means what is at location index? Well, we have a problem here because there is no item at position 6. What's the value returned? So I don't know. There's a bit of debate here. It's not actually going to throw an error because it never actually looks at position 6. So I'm just going to say not applicable, outside of the list. What's the value return? Well, we're going to return -1. And it means it's not been found. Although, strictly speaking, in Python, if you were to look up a value at index -1, what would it actually return? I'll pause, give a class charts pause. Yeah, we've agreed it to be the last one. Okay, work your way through activity 2 and 3 and 4. All of the code that you need is at the start of the Word document. Give me a shout if you need any help. All right, so let's have a look at activity 2. All of the code is in the link at the top. So if we want activity 2, it's all in here. It says the code is all jumbled up for linear search. We need to arrange it, which is sometimes what you might get in a question 3 out of 6, sometimes in a question 4, but more likely a question 2 or 3. Comments will sometimes help you. You don't need to change the code, you just need to rearrange them. I find these quite challenging sometimes. But first of all, start of jumbledness, end of jumbledness. So we just need to move these around a little bit. What can we use to help? Well, we know it's a linear search, so it has to follow this. And the other thing that we can use to help, home goes to the beginning of a line, end goes to the end. The home and end keys are above your arrow keys. If you hold down shift while you move the cursor, you select. It's much faster and more accurate than using your mouse. When you've got something selected, don't copy and paste it, because then you've got 2 of the same, and you don't know whether you're supposed to have 2 of the same. Instead, cut it. Control X. Put it where it should go, and Control V. So now you're using the keyboard like a pro. Let's think. Right. Start from the flowchart. Set index to 0. That looks sensible to me. We need to get the target value. But hang on a second, we're inside a linear search, so all of this has to be indented because we're inside a function which is going to return a value. The return value is probably the last thing that's going to happen, so I'm going to put that down there. If this was an exam, I would probably tick off the things that we've done. So I might even put a little, what shall I do? A little smiley face next to each thing that we've done. Where's a smiley face? There it is. I'm going to make it yellow because it makes me happy. Come on. There we go. So we've set index to 0 and, Word is so irritating when it defaults to the top. There we go. We've done that bit. Next, there it is. Get target value. Well, we've got that already as a parameter. So we now have a while loop to keep going round. I'm going to put that in here. Right, a while. This looks promising. While we haven't found what we're looking for and there's more items, Well, we can't do that until we've originally got some initial values. So we ought to do that first. Why have I done that one and not this one? Well, because it says while not... Oh, hang on. While more items. To begin with, there are more items, so we're setting it to true. That means everything else might have to be indented. We'll see. Let's check and see if we found what we're looking for. If the thing that we're looking for... Oh, there we go. That looks promising. If the thing that we're looking for is not equal to the target, well, this looks confusing. That's the other way around to what we've got here. So that's the no part of this. Which means the next thing we want to do is increment the index. That looks promising. Haha, gotcha. Increment the index. And then inside that if statement, we also want to check and see if we're at the end of the list. This looks promising. If the index is equal to the length of the list inside that previous if statement, because we were going along here, then what we're going to do, we want to return -1, which I guess means setting index to -1. And then we want to stop the loop. How are we going to stop the loop? I guess we want to break out of this. While not found and more items. Well, there's nothing more to see. Nothing more to see. Move along, please. So this sets that to false, which means that is going to be false, which means that is going to be false, which means this will no longer execute. Right, what's going on now? Found. We need to set it to initial value. Have we found it at the beginning or not? No, we haven't found it. We assume we've not found it to begin with. We'll put that up here. However, if we do find it, which is the opposite to this, not this one, so go forward. So we want an else, home, shift end, control X, lined up with that if statement. This indented because it's dependent on that if else statement. I reckon that was going to work. I mean, we might not be able to test it yet. Ooh, maybe we can. Denby is found in location 1. And then we've just got some testy things here. Lovely. I think that works well. So it is sometimes confusing rearranging someone else's code. What helps? The keyboard shortcuts. What else helps? Reading the comments. What else helps? Ticking off the parts of the algorithm if we know what it's supposed to do. You'll either be given a flowchart or you'll be given a written description that describes what it should do. You've just got to think logically and put them into the right order. So save your Word document, upload it to Half-Term 4, Algorithms and Programming 4. Make sure you save it before you upload. There's still 1 or 2 people that upload it before they save it. It just means it's the blank template and you get no marks for it. I tell you every lesson, save it, close it, then upload it. That's what you need to do, please.